Have you ever wondered what allows your body to move, your phone to light up, or even our planet to revolve around the sun? The answer lies in a single word: energy. It's an omnipresent force, silently powering every aspect of our lives, from the mundane to the extraordinary. Energy, in its simplest form, is the ability to do work or cause change. And while it may seem straightforward, energy is a complex and fascinating concept that comes in a myriad of forms. Today we'll be delving into these various types, unraveling the enigma that is energy. So brace yourselves as we embark on an exciting journey through the realm of energy. Now, energy can be as elusive as it is essential, transforming from one form to another. It's a bit of a chameleon, really, always changing its colors yet remaining fundamentally the same. Let's begin with potential energy. Imagine a bow and arrow. When the bow is drawn back, the arrow is ready to fly. That's potential energy, the energy stored up for future use. It's there, quietly waiting, in a stretched rubber band or an apple hanging from a tree. Next, we have mechanical energy. Think about riding a bicycle. The effort you put into pedaling transforms into the motion that propels you forward. That's mechanical energy in action. Now, let's talk about nuclear energy. This is the energy stored in the nucleus of an atom. It's what powers the sun and nuclear reactors. Then we have chemical energy. This is the energy stored in the bonds between atoms and molecules. It's what's released when we burn wood or digest food. Sound energy, on the other hand, is all about vibrations. It's the energy that travels through substances in waves, like the music flowing from your speakers. Heat energy, or thermal energy, is all around us. It's the warmth from a cozy fire or the chill from an ice cube. Electrical energy, that's the lifeblood of our modern world. It's the movement of electrons powering our lights, our computers, our entire lives. Light energy is a form of radiant energy. It's what allows us to see the world around us, traveling in waves, to bring us the colors of a sunset or the twinkle of stars. Finally, we have kinetic energy. This is the energy of motion. It's the energy that a moving car possesses, or a rolling ball. Remember, no matter the form, energy is always there, ready to spring into action. Energy is not just versatile, it's also indestructible. Let's dive into the first law of conservation of energy, a principle that states quite simply that energy cannot be created or destroyed. Rather, it transforms from one form to another, forever in flux, but always remaining constant. Imagine a roller coaster ride. As the car is pulled to the top of the track, it accumulates potential energy. This is energy stored due to its position against gravity. When the car plunges down the track, this stored potential energy transforms into kinetic energy, the energy of motion, and as the car ascends again, kinetic energy is converted back into potential energy. This roller coaster ride is a perfect example of the energy dance, the constant transformation from one type to another. No energy is lost in the process, it just changes its form. The total amount of energy in an isolated system remains constant. This is the essence of the conservation of energy principle. So, the next time you're on a roller coaster, remember, you're not just experiencing thrills, you're witnessing a fundamental law of physics in action. In the grand scheme of things, energy remains constant, forever shifting and shaping our world. So, how do we harness this ever-present, ever-changing energy? Well, it's a fascinating journey from source to switch. We capture radiant energy from the sun using photovoltaic cells in solar panels. These cells convert sunlight directly into electricity. We tap into the Earth's heat, a form of thermal energy, through geothermal power plants. These plants use the Earth's natural heat to produce steam, which spins turbines to generate electricity. We harness the motion energy of wind by using wind turbines. As the wind blows, it turns the blades of the turbines, which then spin a generator to create electricity. Even the food we eat is a source of energy. Our bodies break down the chemical energy stored in the bonds of food molecules and convert it into energy we can use. And how do we distribute this energy, especially electrical energy? Enter the electrical grid, a complex network of power plants, transformers, and power lines that deliver electricity from the source to our homes, schools, and workplaces. The ways we tap into and utilize energy are as diverse as the types of energy themselves. Energy, in all its forms, fuels our lives, our planet, and even our universe. We've traversed the spectrum of energy types, from potential to kinetic, nuclear to chemical, sound to heat, electrical to light. We've delved into the principle of energy conservation, the unyielding law that energy can only transform, not vanish. We've explored the sources of energy, the lifeblood of our electrical grid. All these intricacies make us appreciate the energy that powers our existence. Stay curious, stay energized, and remember to subscribe to Brainwave Trek for more mind-expanding content.